appreciate it.
Luke sucks.
So problem 32 is asking us to calibrate a set of standards for a UV vis analysis of an analyte with a molar absorptivity of 1,138 inverse molar inverse centimeters, wavelength is 625 nanometers, and the percent transmittance needs to be between 15% and 85%. And the question has two parts. The first part asks us to find what would be the most and least concentrated standard we could prepare. And the second part asks us to analyze samples that are below and above the threshold of precision and within the desired precision range.
Okay, so the first thing we need to do is use Beer's law, which is absorbance equals epsilon times B times concentration, where B is path length. And so first we have to find the absorbance from the transmittance. And the equation for that is absorbance equals the negative log of the transmittance. And so for the two ones that we want to look at, the lower absorbance corresponds to the transmittance of 85%. So to find that, we do negative log of 0.85, which equals 0.071. And then the higher absorbance is corresponding to the 15% transmittance. So we'll do negative log of 0.15, and that'll equal 0.824. So now we can plug those absorbance values into the Beer's law equation. And then we know epsilon is 1138. The path length is just 1 centimeter. And then we'll solve for C. And in this case, C, for the lower absorbance, is 7.24 times 10 to the negative 4th molar. And for the higher absorbance, you just do the same equation but with a different absorbance value. So the equation is the same, but in this case the concentration comes out to be 6.24 times 10 to the negative 5th.
So we just solved part A for the most concentrated and least concentration standards we can use to get the desired precision in the analysis. Now we're going to solve part B. So the 10 micromolar sample is a bit too dilute to detect with the desired precision, and so we thought of two ways to measure it. And the first way would be standard addition, where we would add a known amount of standard to each sample and then get a new calibration curve. And then the other way was to redefine the 0% transmittance with a new blank containing less than 10 micromolar of the standard but more than the original blank. So we would effectively move the 0% transmittance up and thereby move the 10 micromolar concentration into the desired range. For the 0.1 millimolar, that's already within the range, so it's fine. We can analyze it as is. And for the 1 millimolar, it's a bit too concentrated, so we just needed to dilute that sample to at least the maximum allowed concentration, which was 7.24 times 10 to the minus 4th molar. So using these three techniques, we should be able to analyze the three samples of the concentrations given.